While machine learning can be an amazing solution to solve business problems, there are times when it may not be suitable. It is very easy to get caught up in the hype around artificial intelligence. The term machine learning itself may evoke expectations of a magic bullet solution, which it might not actually be. At this stage, there are still many uncertainties around the ethical and legal considerations. For example, think about a self-driving car that causes an accident due to a decision taken by the algorithm. In this case, who is responsible? And what happens if we don't know how an algorithm makes decisions? And what happens if there is bias presented in the program, which leads to discrimination and socially unacceptable decisions? In this lecture, we will briefly introduce some of the challenges, and then in the future lectures, we will explore each of these challenges in more details. The first challenge is high volume, quality, and relevant data. Some machine learning methods need loads of data to work effectively. Specifically, more modern machine learning techniques, such as deep learning, requires lots of high-quality data that may not be available, and also processing the large amount of data requires storage and computational resources, which can be very expensive. Complex problems. Machine learning methods usually work pretty good for simple problems, while they cannot cope with very complicated problems when specifically human intentions and complexity is involved. Complex problems have many variables that affect each other, and therefore it's hard for a machine learning model to make sense of everything. No free lunch theorem. This theory says that there is no single algorithm or approach that is universally superior to all other ones, and different algorithms may perform better or worse depending on the specific problem that they are applied to. Bias variance trade-off. Bias variance trade-off is an important topic that we will explore later when we work on tuning up our machine learning models. Bias variance trade-off says that a model with high bias and low variance is too simple, meaning that it cannot capture the underlying patterns in the data. On the other hand, a model with low bias and high variance is too complex, meaning that it can capture noise or random fluctuations in the data. Bias variance trade-off can be seen and explained on this diagram. So when the model complexity is very small, which means that the model is very simple, we will have a high amount of error because the model is not able to capture the patterns in the data. It's very specific. As we increase the model complexity, then we capture more variance. But then if we make the model too complex, again, the total number of errors will increase because we are going to capture lots of noise as well. There is an optimum spot where the model complexity yields the least amount of error, and that is where we want to set the parameters of the model that doesn't cause errors but also captures the most amount of patterns existing in the data. The next challenge is causality. Causality refers to the ability to infer a cause and effect relationship between variables from observational data. It's hard for machine learning models to understand the causality due to the existence of too many variables in complex problems. For example, in the medical field, there might be so many causes for one condition or one symptom, and a machine learning model may not be able to comprehend properly that if those variables are actually representing a disease in a person, and it may just raise the false alarms. As I said, in the upcoming lectures, we will explore any of these challenges in more details.